Hello, my name is Mark Anderson. I currently live in Pennsauken, New Jersey. I'm a recent graduate from Bethany College with a Bachelor of Science degree in mathematics with a focus in physics. I'm making this video because I'd like to really talk about my senior capstone project at Bethany, but I wanted to touch on my grant that I received from NASA, the West Virginia Space Grant Consortium, where I received a $2,000 scholarship and about $500 in grant money to create a radio telescope that I actually handmade myself from a bunch of different satellite dish parts, TV satellite dish, where I took out onto a hill and I hooked a meter up to it, and I actually took readings of different stars, and I tried to get readings of the International Space Station and everything. Currently, I do not have this project. The college actually owns everything that I did on that project, so if you would like anything from that, I'd actually have to go through them for that. But my senior capstone project, I created a fuel-independent maglev propulsion system, which was used to reduce the travel time from Earth to Mars when Mars is at its closest, down from 260 days to only just over 22 days. This propulsion system was then integrated into a spaceship that I also designed. And with the help of my friend who has a degree in mechanical engineering, I was able to 3D model that. Here's a small review of what you're going to see in my capstone project that I'm actually going to submit with my application. This ring, outer ring right here, is actually where the inhabitants on the ship are going to live. The ring is going to spin, simulating gravity. The way the propulsion system works is there's 4 tracks. Each one of these tracks I have listed is 24 feet long. The mass on each one of these tracks is going to accelerate from end to end, but they're not all going to accelerate at the same time. The way that this works is the first mass will accelerate from start to finish, and the second mass will begin accelerating as the one before that starts to slow down. So there is a constant acceleration and deceleration here, but these tracks actually rotate 180 degrees. So when the mass goes from start to finish, rotates 180 degrees, now the mass is at the front, there's no momentum lost, and you can have constant acceleration. This is how I plan on using this propulsion system to drastically reduce the travel time. And I had 2 professors with PhDs actually review this. So I'm pretty hopeful in the future of this project, not only in the fact that having a maglev propulsion system could actually be integrated into a spaceship at some point, but also because this project gives you and whoever else wants to review it a very good indication of my level of analytical skills, data analysis skills, my quality of work I'm able to produce, and definitely organizational skills, as this project I worked on for about a year and it's about 45 pages long. So I would just like to thank you very much for taking the time to review this video and review my application, and I am definitely looking forward to hearing back. Thank you.